Let's do one more here and proving that it was to see if we have a proportion or not. All right, I'm going to write down two more ratios. We've got 12 to 15 and 16 to 25. And this way, this time again, guys, I want to really challenge you to maybe simplify this. We've got some pretty large numbers again. See if you could just simplify these. Can we simplify 12 to 15? Can we simplify 16 to 25? Is there a number? Let's talk about 12 to 15. Is there a number that could go into both 12 and 15? What would that be? 3, right? So I could divide by 3 here and divide by 3 here, and then that brings me down to 4 to what? 4 to 5. Now what about 16 to 25? Anything I can do with that? 25 is kind of the deal because this ends in 5. Remember those whole divisibility rules? Because it ends in 5, what number can uh, yeah, I mean, I'm trying to think. I don't know of a number other than 1 that could go into 16 and 25. So can we say that this one's already simplified? Is that a safe assumption? So I think it is. And so because this is already simplified and I'm looking at this compared to this, boy, these don't look anything alike. So therefore my answer would be what? Do these form a proportion or not? No, they don't. Okay. Now again, you could have cross multiplied. You could have done 15 times 16 and then 25 times 12. You're going to get two big old numbers. But they probably are going to be different, huh? They better be different. If we're saying no, those two numbers better be different. All right. Well, today we're going to be dealing with something very similar, and it involves proportions. It involves algebra. So nothing. It's just that we're sort of combining what we've learned in the past with what we've learned very recently. Okay. There are times where let me just write this down, and you tell me what this means. Tell me what this means right here. I mean, what could I say? Remember, are we dealing with fractions? We're not dealing with fractions. They look like fractions. They behave like fractions. But let's get over that. That we're really not talking about fractions here. We're talking about ratios. We've got two different ratios. Okay. So what can we say about this? I don't want to know what the missing number is. Don't get me wrong. I'm not asking for what the missing number is. What can we say? What if I were to take this and put it into words? What could I? What would it? How would it be said? How would it be said? Yeah. And instead of saying, okay, that's good. She said x is to 6 is equal to 10 is to 3. Is there another thing I could say instead of is equal to? What? Well, equivalent is a good one, but that's not what I'm looking for either. What is in proportion to? Okay, remember that? Say it. In proportion to. Okay, because that's what we're talking about today. Yesterday was all about here's two ratios. Are they in proportion or not? Yes or no? Okay. That's not the question today. This is already saying what? That it is in proportion. We're saying this is in proportion to this. What's the challenge? Well, the challenge here is we got to figure out what this number is. That's where the algebra kicks in. Okay, so here's how we solve a problem like this. Okay, we're going to be using a lot of cross multiplication today. And honestly, you guys, well, here's what I used to say when we were doing our California, our CSTs, our STAR test. I used to always tell my class, all right, guys, this is a heavily, heavily tested skill. One thing that we really need to nail down hard. Now, honestly, with the whole Common Core, deal. I'm not sure whether this is. I know this is on our new standards. I don't know if it's gonna be as heavily tested. I have a kind of a suspicion that it is. This is a very useful tool to have. And remember, math is more about conditioning your brain than it is actually solving problems. Okay. I don't know if in life you're going to actually have to solve a problem like this, but your brain might have to think along the lines of this. Very much so. That's a real life kind of problem solving skill that you need to have, and that's why we do math. Yeah, everybody's like, "Oh man, why do I need algebra? When am I ever going to use algebra?" I don't know, but the same can be said for like, when are you ever going to have to run a mile? You know what I mean? I don't know. Is it good for you to be able to run a mile? Yes, it means you're in good shape physically. Are you going to ever have to solve an algebra problem? I don't know, unless you end up being a knucklehead like me teaching it all the time. Other than that, probably not. But it is an indicator of a healthy brain that is in shape. See what I mean? So, anyway, that being said, here's what we need to do with this. You guys are good with cross multiplication, right? You love to do that. I noticed a lot of you when we were solving when we were looking at the ratios and proportions, a lot of you weren't really big on simplifying. Even if the numbers were larger, you still wanted to cross multiply. And you know what? You're going to love today then, because we're going to do a lot of cross multiplication today. So here's what we'll do. We're going to take a look at these numbers and these numbers. Now, I always like to start off with this. What is x times 3? How would I write that? What is x times 3? I don't know, because I don't know what x is. So how do I write that out then? James. Okay. All right. Here's what I would do. When we're multiplying, this is called a constant, and this is called a variable. Okay. When I'm multiplying a constant times the variable, which comes first? The constant or the variable? Constant comes first. So I'm going to rewrite this as 3x, right? This shouldn't look too unfamiliar to you. This means 3 times x, right? I don't know what it is. See, what I'm doing now is I'm building an equation. 3 times x equals, now I multiply 6 times 10, which gives me what? 60. Hey, does this look familiar? Have we solved problems like this before? Okay. In words, how would we say this? We would say it as 3 what? Times x. 3 times x equals what? So now we go back to like, oh, I'll say September when we were doing this kind of thing, right? And we said, all right, we need to now what the variable? Isolate it. Put it by itself. And to isolate it, I have to do the inverse operation, right? If my operation is multiply, what's my inverse? Divide. So I'm going to divide by 3 here, divide by 3 here. Yeah? Okay. So that gives me, 3 divided by 3 is 1, and 1 times x gives me just x. See how that kind of gets rid of that coefficient of 3, or that constant? Okay. Now 60 divided by 3 gives me 20. And guess what? What I have? I now know what this actually equals. Okay. I know that 20 over 6 is in proportion to 10 to 3. This should look like what we did yesterday. What did I have to do to 20 to make it 10? Divide by 2. Divide 6 by 2, and what do I get? 3. Now, you don't have to do this step, but in your mind, this is a good thing to do because it can prove whether you have your problem right or wrong. Okay? All right, let's look at another one here. In fact, why don't you guys go ahead and turn to page 247, and you guys can start with number one. Uh, start with number one on your whiteboard. Now, here's what I'm going to need from you. I don't want any shortcuts taken today, okay? I want you to first of all write out. I want you to write out the proportion. 6 to 10 is in proportion to 36, 36 to x. Your next step is to build the equation. Now, some people like to skip this step. Do not skip this. I will. If you skip this step in showing me your work, I'm going to give you your work back and say redo the whole thing because I want to see the equation. This is good practice for you. So we have 6 times x. Again, that's 6x. And 36 times 10 gives me 360. So there's my equation. Times 36 is 360. Divide by 6. Divide by 6. X is going to equal what? 36? 60. Yeah. Okay. See this format right here? See that? That is exactly what I want to see your problems look like. Okay? Start off with the proportion, build an equation, give me the answer. Don't skip anything there. Okay? Let's go on and do number 2. Number 2, we have 4 to 7 is in proportion to 5 to p. Oh, there's that fun variable again. Thank you so much, publishers. Now, this one, some of you that are kind of good with numbers are looking at this and you're like, oh, this is not going to turn out like nice and even like the other one did. Okay? This one you might have to, this one might have a remainder. You might have to add a 0, bring it down until you don't have it, until you don't have that anymore. Let's see how you do with this. Seeing that we've got this, 7 times 5 is 35. You have you guys all to this point by now? 4 times 2. If it helps, then draw some circles around there. Sometimes that kind of focuses your mind on what numbers are working with what. 10's not going to work. How would that be 10? Okay, we got to divide by 4, divide by 4. Okay, so p's by itself, but now over here on the side, I'm going to have to go 35 divided by 4, right? All right. Can 4 go into 3? No. Can 4 go into 35? How many times? I would agree with that. 8. 8 times 4 is 32. Difference of 3, right? Add a decimal point. 0. Bring that sucker down. 4 goes into 30. How many times? 7 times. 4 times 7 is 28. Difference of 2. Add another 0. Bring it down. Finally, 4 and 20 goes in 5 times evenly. No more remainder. We're good to go. Okay? So my answer is P equals 8 and 75 hundredths. Okay? So it's not always nice and clean like this one was, where it's just a whole number, no remainder or anything. Sometimes you might get this, but this is probably going to be fairly rare. I would imagine most of these are going to be somewhat whole numbers. All right, one more. Well, not one more. One more for right now. Um, oh boy. All right, that's okay. Let's not fear here. Okay, no fear, no fear. I know we got decimal points, but it's okay. It's okay. We've got 12 and 3/10 to m is in proportion 75 to 100. All right. Again, same thing. We're going to deal with these two, these two. Here's the easy part. 75 times m. You guys got to do the hard part. I'm glad I have a calculator. Actually, you don't really need a calculator for this part. How many zeros are in 100? 2. So all you need to do if you're going to multiply this number by 100 is, because there's 2 zeros, right? Move this over twice, and you got your answer. Yeah, seriously. So if I move the decimal point over twice, okay, if I have 12.3 and I move it over twice, what do I have? 1,230. Okay. I mean, that part was actually fairly simple because that good old 100. The rest of this, I don't know. I mean, you're going to have to do some division now. Okay. 75 divided by 75, 1,230 divided by 75. This is the tricky part. But you can do it. Go ahead. Keep going. Keep adding a zero, bringing it down until you don't have a remainder anymore. Okay. Anybody have an answer yet? We're still working on it. Boy, the wheels are turning, aren't they? All right. Words up when you're done. Oh, no, no. No, 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 no. Kind of a high number, don't you think? Now, I will agree with you on 4/10 part of it. It's the whole number that I have a big problem with. Yeah, here's what I see a lot of you have. I'm going to go ahead and share this, but I still want you to figure out how this, if you didn't get this, figure out why this was. It was 16 and 4/10 as your answer. 16 and 4/10. Okay, we can go over that division if we need to.